Corporate finance practice problem using Excel. Net present value, the NPV versus the internal rate of return, the IRR, the problem 1. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information, left-hand side, populating that information into the blue area on the right-hand side. Comparison between the net present value and the internal rate of return. So these are kind of calculations where we have the initial investment that we're getting some return, or we're projecting the return out into the future, typically multiple years. And when we have long-term projects such as that, we want to take into consideration time value of money. The two primary functions or calculations for that are the net present value and the internal rate of return, which are indeed related. You want to think of them as related to each other. So we have the investment. We're putting $80,000 down. That's what we're starting off with. And we want to get a return. We're estimating the return for year 1, 2, and 3 will be $45,000, $37,000, and $25,000 respectively. We have a discount rate of the 12%. Discount rate might be called the hurdle rate. It might be called the required rate of return. Might be the discount rate. This is the rate that we're going to be building into when we create our net present value calculation. It will include typically what we expect to have as a return, and therefore, if our net present value calculation is anything above 0, it's a project that we might consider taking, considering the fact that we're getting a 12% return. So this doesn't just mean inflation that's included in there, right? It includes our rate of return that we want. So a 0 means that we got our return back. Then we ask the question of, well, what rate would make this series of payments 0? What rate would make that series of payments 0? That would be the IRR, the calculation. No one calls it by the way. Doesn't sound that nice, but I think it's good to remember that way. It helps me remember it. So let's go ahead and do the calculation here. So we'll do the net present value first. We're going to say 0, 1, 2. We have to format our payments here. I'm going to select them and just drag them down just to use the autofill. And then alignment and center them. And basically we just want to format our payments so that the negative outflows are negative, inflows positive. So I'm going to make that 80,000 negative. I'm going to put it in period 0. This column to the left, very important to simplify your process for calculating the net present value, because then we can make the formula reliant on them. We can then autofill without a hard-coded number. So then we're just going to be dragging over our $45,000 payment. I'm going to drag that down. Once again, useful to be pulling this information from the data set on the left so that you can change the data set and run different scenarios very easily in Excel. So you get used to using Excel efficiently here, right? So we got the font group. We're going to underline. And then if we were to calculate this, the sum it up. And then we're going to say if we didn't have the present value, 27,000 would be the net profit after the 3-year time period. But now let's do the present value calculation. I'm going to do it on the first item here, even though it's still going to be 80,000. You don't need to do it here, but it's helpful to have all your column F uniform. And so I'm going to do the calculation even though I expect to get to 80,000. So negative present value, shift 9, rate 12%. That's the discount rate or the hurdle rate or the required rate of return that we're looking at down there. Then the number of periods is 0 and comma, because it's not an annuity but present value of 1. 80,000 is the future value. There we have it. Same number. Pretty boring. Let's do it again. See if we can have something more interesting this time. Present value, shift 9, rate 12% down here, then comma, number of periods now 1 period out, and then comma, and now we're taking that 45,000. If we bring it back 1 period using the discount rate, required rate of return of the 12%, we're saying it's worth 40,179. Let's do it again. Negative present value, shift 9, rate 12%, comma, number of periods now 2 periods out. Notice how we're picking up this cell to the left. Very useful. You could hard code the 2, but then you can't copy it down easy because then the 2 gets stuck in there. And what I wanted to do is take the 3 that's going to be there next time. So keep that in mind when we do the autofill soon. Comma, for future value 37,000. Present value in that at the discount rate And just note, when I say I'm present valuing it at the discount rate, that can be kind of deceiving because we're using a present value formula to bring it back. But when I present value it, I'm including the rate of return that we want, which is basically the rate that includes what we think we could get from the next best project. So it's not like it's just time value of money. It's not like it's just interest there that I'm bringing back when I present value it. We're bringing it back, and it's including the fact that we're getting, a 12% return on the investment, which is our required rate of return. Okay, one more time. Negative present value shift 9. We're going to pick up the rate at the 12%, comma, number of periods 3, comma, future value 25. There we have it again. Let's delete these now and do it using the autofill way, the easy way. So let's delete these, and I'm going to double click on this 80,000. This cell that's outside the table, that one needs to be present valued so that when I copy it down, it does not then go down. It's in cell B9. I'm going to put my cursor in B9. I'm going to select F4 on the keyboard, $ before the B and 9, telling Excel, please don't move that cell down, and enter. Then we're going to put our cursor back on it, drag it on down, and there we have it. Done it again. If I double click on the last cell just to see if it does what we want, it did do what we wanted it to do. Thank you, Excel. Font group, underline. Let's sum it up now. Sum it up. Summing it up. Now it's worth the 7,469. Now you might be saying, well, if I present value it and I get that 7.69, that's not, that's still good profit, but that's not that much profit and whatnot, But that's not how you want to look at it. What you're looking at is anything above 0 means that we got the 12% return included in it. So anything above 0 means that we got basically our rate of return in there if this is our required rate of return rate. So then the question, of course, is, well, that's good. So I might accept it under those conditions, but then I might want to say, well, what is my rate of return that I'm getting right now? I know it's above 12%, and the higher this number is, the better, but what is the rate of return in percent that I'm getting? That might be useful for me to compare it to other projects if I have multiple projects above the required rate of return, and I want to compare them in more detail. So for that, we want to get the internal rate of return calculation down here. Now, before I do that, I'm also going to calculate the net present value formula in Excel too. This is a formula that you can use here, but I don't find it to be quite as useful because even when using this net present value formula, you have to basically format your data this way, right? And if I'm already formatting my data in this format, meaning negative numbers and then positive numbers in this format, then I would rather present value each year and see the more detail of seeing it being present valued. So most of the time it's kind of nice to display it this way. But of course you could do simply, once you have this data set up, you have to do the same system. Once you have that set up, you can do your net present value calculation this way, equals the net present value shift 9. Now it's a little bit different, it's a little bit weird. You got to pick up the rate, which is the 12%. That's not weird, that's normal, comma. But then the values, instead of picking up like all of it, negative and positive, we're going to pick up just the positive values down here, and then I'm going to close up the brackets, and maybe I shouldn't say it positive, negative. I'm going to pick up everything after the initial investment here, and then I'm going to add to it the initial investment. So then I'm going to add to it the initial investment at period 0. So it's a little bit different than some other kind of formulas that gets to our same 7,469. I don't see that as being a whole lot easier than doing the present value if you set up your table properly and just copying it down. But let's do it one more time just to check it out. We're going to say this equals the NPV shift 9, the rate 12%, comma, and then the value is the range, but you're not picking up period 0. Everything other than period 0, you got to close it up, shift 9, close up the brackets, and then add to it period 0 plus period 0, which is that 80,000 represented as a negative number. So meaning if I picked up this 80,000, it wouldn't be, I'd have to say minus possibly the 80,000. If I say this number, I'm adding a negative 80,000, and that's going to give us our 7,469, matching our 7,469 down here. Now let's do the IRR, the calculation. For that, we could do it two ways. We could use the goal seek kind of function here, and I think that's the most intuitive way. And then we can basically use the IRR formula to do it this way as well. So let's first use the goal seek. I'm going to take our discount rate. I'm going to plug it in down here, 12% down here. And then I'm going to use this 12% to calculate our net present value, get into the same result. And then we're going to tell Excel using goal seek to change this rate to make this number 0. So, and that will find the rate that makes the net present value 0, which is the internal rate of return, the IRR, the IRR. So let's do it. So we're going to say this is 0, 1, 2, 3. Same thing we did last time. Centering this, the alignment and center, the total, and then I'm going to say negative of the 80,000. I'm just building our same data set. The 45,000, we're going to take that and autofill it down, underline under the 25. Let's do our present value calculations the easy way this time. So I'm just going to say negative present value, shift 9. This time I want to pick up the rate down here. I see that rate, I don't want it to move down when I autofill it because it's outside the table. Therefore, I'm going to select F4 on the keyboard, $ before the E and the 15, telling Excel, don't you move that cell down when I autofill it. You leave that cell where it is next time when I do the autofill. So then the number of periods is going to be 0, future value 80,000. Enter. Once again, it's 80,000. Not very interesting, but because we did it properly, hopefully, we can take the fill handle here and drag it down, autofilling it, and then we have our same calculations that we had up top. Let's sum it up. SUM, the sum, and sum it up over here equals SUM, summing it up. Same data set. Now, we want to tell Excel, change this cell to get that to 0. So you could do it manually. We could say, well, what if it was like 11%? How about like 13%? You know, how about 14%? And so on. And so we can tell Excel to do that for us. So let's go to Excel and say Excel, data, information, forecast section, what if analysis. This is where we do our pondering what if, staring at the clouds in the sky and saying, what if like this cell was set to be 0 by changing this cell down here. So we're telling Excel, I want you to please set this cell to be 0 by changing this cell. What if that happened? Then that would change this cell to 17.93, which is our IRR, our internal rate of return. The internal rate of return is the return, the rate, that would set this data set to 0, which is basically our rate of return. So then if we plugged it back into our net present value, it would make it 0, right? We could calculate the internal rate of return this way as well. And once again, I have to set up the data set in this format. So, and then I can just basically sum it up. So I have to have negative numbers for the outflow, positive for the inflow, and then just say the IRR is really simple. Once you do that, it's just the it's just like the sum function, except you have an IRR instead of the sum, and then shift 9 bracket, and then you just, you know, select that range, just like with the sum function, and enter, and there you have it. There's the 17.93. Easy as that. So easy as PZ. So then we're going to then go to the net present value. We could do this again. Net present value with this formula, now using this rate, should give us 0. So we're going to say, let's do the net present value, shift 9, rate 17.93, and then comma, we have to pick up this range of data, everything except period 0, which is this stuff, close up the brackets, shift 9 for some reason, and then plus the negative amount from period 0, which is the 80,000, which is represented as a negative number. We're saying plus here, a negative number. Enter gives us 0, which is what we expect because we use the IRR, and that is the rate at which the present value of the cash flows would be 0. So if we were to compare this to other kind of investments, we might be saying any investment over 0 for the net present value is one we would invest in. And if we have the money, we invest in multiple projects. Or we might be comparing and contrasting multiple projects, and we might say, well, we have some that are over the 0 point. Maybe it would be nice for us to compare the rate of return on those projects. If we calculate the actual rate of return, we'd be saying, okay, I'm looking for all the projects that have over a 12% rate of return, and then maybe I can compare them more easily by rate of return comparison between multiple projects or something like that to help us decide which projects we may want to invest in.